Okay, we're going to get started just taking a look at some of the solutions here. Um, the first one says we want to order the parabolas in each set from narrowest to widest. And we have to look at it in the form y equals ax squared plus bx plus c. So all of these are kind of in this form. A lot of them are missing this little bx term. So if you look at this 1 over 3x squared, the 1 over 3 x squared minus 7, the term that's connected to our x squared, which in this case is that little 1 over 3, determines how narrow or how wide our graph is. And generally, an a that is small, like a fraction, that is below 1, makes it very wide. An a that is larger makes it very narrow. So here, 1 over 3 is very small, and that's going to result in a very wide parabola. 3x squared, that's our biggest a value, and remember, the larger it is, the more narrow it is. That's going to give us a narrow value. And then our x squared minus 7, it's kind of right in the middle, so that would be our middle value. So if we're labeling them from narrowest to widest, this would be number 1, that would be number 2, and this would be the widest, so that would be number 3. For B, we take a look at the a values, and we want to find out, okay, which is our smallest a value, because that is going to be our widest. This one is negative 1/2, which is negative 0.5, which is our smallest value, which means this is going to be our widest. So that would be number 3. What would be next? Well, this is just a little bit bigger than that, which is going to make it in the middle, a little bit more narrow. It's going to be number 2, and this is going to be the most narrow. That's going to be number 1 because it's got a value of 4. A minimum, or neither. Okay, we can do that. So let's first off find our y-intercepts. So how do we do that? Y-intercept, just set your x equal to 0. Another really good trick is just look at this last number here. This is always going to be your y-intercept, and I will show you by doing the first one. Y equals x squared minus 4. It's going to be y equals 0 squared minus 4. And what does that become? Well, that becomes y equals negative 4. And look what I highlighted, negative 4. So what's our intercept? 0, comma, negative 4. For this one, it's just going to be 0, comma, 7. And we could do the same thing, 0, comma, 45. 0, comma, negative 8. You're always looking at that last number. Why? Because it doesn't have any x's involved. So if your x gets sent to 0, everything with an x is going to disappear. But this doesn't have an x involved, so it's not affected when you put x equals 0 in. So we have our y-intercepts done. Now let's look at whether it's a max, a min, or neither. Remember our little chart. If our a is positive, like this, that means it opens up, which means we're going to have a minimum. If our a is negative, opens down, and you have a maximum. Okay, so here our a value is 1. Do we have a maximum or a minimum? It's a minimum because it opens up, minimum because it's positive. Here we have a maximum because it's negative 5. Here it's a negative 2, so if it's negative, it's going to be a maximum as well. Here it's negative 1 over 3, it's going to be a max. And here it's a negative 1/2, which is also going to be a max. Perfect. Next, graph each relation from question 2, then find the zeros. We don't actually want to do the graphing, we just want to find the zeros. So let's go ahead, I'll start with A. So y equals x squared minus 4. So what we actually have to do here, and this is a little bit of a trickier one, and you know what, we're actually going to scrap finding the zeros here because it's going to take a little bit of techniques that we haven't really touched on unless we graphed it and then just took a look at it. So we're actually going to eliminate that question altogether. Number 4, a ball is dropped from a platform. Its path can be represented by the relation. Here's our little quadratic equation here. From what height was the ball dropped? So what is our starting value? AKA, what is our y-intercept? And how do we get it? Well, we can just look at this number here, or we can do the math. H equals negative 5t squared plus 45. We're going to substitute 0 in for our value of time because that's what we started off. We started off at 0 seconds. and this gives us 0 plus 45. So what is our coordinates? 0, comma 45. Now, how long did it take for the ball to reach the ground? If this is our graph, we start off here. We want to figure out what are our roots. Because if this is our ball, it's going to hit the ground somewhere around here. So let's look at B. To figure out our roots, we need to do some factoring. So we have h equals negative 5t squared plus 45. First thing you always want to do is you want to try to common factor. So can we common factor? Of course. We can take a negative 5 out, and then we're left with t plus 9, t squared plus 9. And t squared plus 9, we can actually do a whole bunch of stuff with this. Let's think back to our trinomials. We need to figure out two numbers that multiply to the last value, so multiply to the last value. And what's our middle value in here? Well, we actually don't have that third term that we're used to. Why is that? Well, because it is 0. So what two numbers multiply to 9, and sorry, this should be negative 9, because I took out a negative from it, and add to 0? Well, it means we need the same number, so we're going to need a 3 and a negative 3, and 3 plus negative 3 also adds up to 0. So those are actually going to be our two values. So we have negative 5, t plus 3, and t minus 3. So we did the exact same thing that we've always done. Maybe it looks a little different just because we didn't have that middle value, but that just means it was a 0 in there. So that still doesn't answer my question. How long did it take the ball to reach the ground? Well, from here, now we have two zeros. Remember, we need to flip the signs. We have negative 3 and we have positive 3. And that makes sense because if we look at our graph here, this might be negative 3 and this one's positive 3. So if I asked you, when does the ball hit the ground? Hopefully you wouldn't tell me negative 3 seconds. That doesn't make any sense because time is not negative. You would say it is positive 3 seconds after being dropped. Okay, we have our scuba diver and we have our equation here. How deep was the diver when she started to ascend? That's going to be our y-intercept. So let's take d equals 2.5 t squared minus 250. We'll put a 0 in there. And we end up with negative 250, which makes sense. They are 250 meters deep. Okay. How long did it take them to get to the surface of the water? Well, here's our graph. And we started at negative 250 and we hopefully move up until we eventually hit the surface of the water. So that means we're going to be looking for some zeros. So let's do some factoring. Oh. D equals 2.5 t squared minus 250. So let's factor. We'll take out that 2.5 and we're left with t squared minus 100, right? If we divide that by 2.5. Now we have the exact same situation we just ran into. So we need to figure out which two numbers add up to 0 because there's no middle term, right? And multiply to negative 100. So what two numbers are we looking at? Well, 10 and 10 multiply to 100. So if we have positive 10 and we have negative 10, that's going to fit the bill. So when we factor this thing out, we get 2.5 and t minus 10, t plus 10. So our two zeros there, remember we need to flip the signs. This becomes 10, this becomes negative 10. Now, which time makes sense to you? Well, is it negative 10 seconds or is it positive 10 seconds? Of course, it would take positive 10 seconds to get to the surface of the water. For C, suppose they had 20 seconds of air left in the scuba tank. Would they reach the surface safely? That is very scary. Let's take a look. So 20 seconds is going to be our time when we look at our equation right there. So we're going to substitute the 20 seconds in for t, so we get 20 squared minus 250. And now we're going to take a look. We're going to do this on our calculator. If we get a negative value, well, this scuba diver had a tough day. But if we get a positive value, then that means we are going to be in very good shape because we will be above the surface of the water. So did they have enough time? When I do the math on my calculator, I get d equals 750, which means we definitely made it above 0, above that surface, so they survived. 8 says a large square with sides, and we have a smaller square with sides 5 meters long. What is the minimum possible area of the larger square? So we have a large square with sides x meters long. Perfect. So how do we get area? So we know area is going to be a square, so it's x squared, right? What is the minimum possible area of the larger square? Well, the larger square can't really get much smaller than this smaller square in here. So what would be the smallest it could possibly be? Well, if the smaller square has an area of 5 times 5, we know this area in here is going to be 25. So the smallest this large square outside could be would be like right on top of this border. So the smallest it could be would definitely be 25. So B, it says graph this relation and find the dimensions of the large square if the difference between the areas is 75 meters. So a couple ways we can do this. I think the easiest is probably to make a table of values, right? And we know the minimum that we can have for this side length here is 5. So we're definitely going to start our table of values at 5. So we'll put our x is going to be 5, 6, 7, and what is our area going to be? Okay, so what is our area? Well, if our side length is 5, then this gray thing is right on top of the white box, and that means our area is going to be 0 because they're literally right on top of each other. If it's 6, then it will be 11 if you do the math, x squared minus 25, so we have 36 minus 25. The next one would be 24, and we could in fact keep going, and this one would be 39. So if we drew a little graph here, and we started 0, 1, 2, 3, 4, 5, here's my 5, 6, 7, 8, and we had 10, 20, 30, 40, 10, 20, 30, 40. When x is 5, this thing is at 0. When x is 6, it's at 11. When x is 7, it's at 24. And when x is 8, it's at 39. So you can see it's starting to already curl up. So when does it get to 75? Well, if we continue this graph, probably be around the 9.5-ish mark. Okay. 10, the graph of the quadratic relation y equals ax squared minus 15 passes through the point 2, 1. Okay? Find the value of a. So we've got to try to figure out what this is. Well, how do we do that? I mean, we don't have too much information, but we do have this point. And what is this point? Well, this is the x value, and that is the y value. So what we're going to do is we're going to plug those into the equation. So the y value is going to be 1. The x value is going to be 2. So we have a, and then we have x squared. So we have 2 squared minus 15. So 1 equals 4a minus 15. We'll bring that over to isolate a, and we get 1 plus 15 equals 4a, and we get 16 equals 4a. Divide both sides by 4, divide by 4, and you get a equals 4. Perfect. The next one, y equals negative 2x squared plus c, says this one passes through the point 5, 10. So we're going to do the exact same thing here, but now we need to solve for c instead. So this is going to be our y, this is going to be our x, and we can go ahead and do that. So our y is 10 equals 2 times x squared, which is 5 squared, plus c. So we get 10 equals 2 times 25 plus c. 10 equals 50 plus c. Bring that over, you get 10 minus 50 equals c, and we get negative 40 equals our c value. And that's it.